In this video, we're going to talk about using the logging framework within Python, as well as different data types. So Python has a lot of different data types we'll use, such as strings and integers and lists, and we're going to go over how to use all of those and what it means in your code to use the different data types. So let's dive right in. Let's start with a new file in the structure for this 60-minute series. We'll call it logging data types. So there's a few things I wanted to talk about. In our last video, we talked about how we can print information out to our console. Well, printing is good when you want to send data from your application, such as you're creating a CSV file or you're creating a JSON file and you want to print something out to your standard output. Well, if you're building a complicated application like a web application, a web server, you won't want to use the print functionality for debugging or logging metrics or logging components of your application. You want to use the logging framework. So the reason I have this as our second video in the series is to get you in the habit of using this logging framework early, instead of building all your applications using print to debug, then having to go back and change them. So let's start by importing this logging library. And here we want to make a logger object. This logger object we can give a name, and that's what I want to do right now. Logging.getLogger, and I'm just going to give it a name, and I'm going to use, remember, that built-in name variable, so we can have something we can understand when we're looking at it. Now, alternatively, if you're building classes within your application, you can use a class name. So we'll just call this one Fowie.com logger. So let's do some basic logging to our output. So we'll send logger debug. Debug is a log level. In Python, you have a debug log level, an info log level, a warn log level, and an error log level. And we'll also talk about exception handling later. So the reason we have different levels is, depending on the stage of your life cycle of your application, you can output extra information. So we would use debug to trace down to the smallest finite piece of information we need to see, why our code is slow. We can put some timing in. We can see exactly what's happening within the application at any point in time. When I run my applications in a debug log mode, I am going to see thousands of lines of output. That's great for development, but as you build your application and you start to deploy it, you'll raise that base log level that you have from debug to info. So when you have an info log level, you'll see important things like I made a new database connection, or some event happened that you would want to get no matter what time your application is running. Above that, you want to do some warnings, such as a downstream system is no longer needed or is no longer available. So this is a condition we can handle in our code, but it's kind of important, and we want to warn you that something worse may happen soon. The error log level is to show something really bad happened. So here I'm going to show you an example of all of those. So logging.debug, this is a debug message. And we'll go down to our Python interpreter and we'll run our logging data types. And I didn't get anything. And I'm going to tell you why. I haven't actually configured this logger to tell it which level to output. But I'm going to show you how we do that after we print out a couple more things. So I have a debug, an info, a warn, and an error log level. I'll run my code, and you'll see here that Python 3.7 is saying not to use warn, to use warning. Okay, so we'll change that to warning. And then, but we can see our warning log level, our error log level. And now that I've changed that line of code, I'll output and I'll see my warning and my error. That tells me by default the debug and info log levels are withheld from output. Here we'll do logging.basicconfig. This is saying I'm going to do a global configuration, and here I'll set my level equals logging.debug because I want debug and above messages to come out. When I go to my console, I'll run that again, And here you'll see my debug info, warning, and error log levels. And so say I'm in a development environment, that's what I want. When I start rolling it up into maybe a QA environment, I'll take out the debug because I just want to know about the info. And then when I'm in a production environment, I probably only want to see warning and error messages, because in an enterprise I would take these errors or these messages and put them into something like Elasticsearch so I could troubleshoot later. I'm going to move into our data types now, and I'm going to show you different things we can do for data. So right now we've dealt with a lot of strings. So we'll have a string variable, and I'll set it to a string value. We also have an integer or a number, numeric. I can set that to an integer value. We can do a float where I can say 100.1. Floats are decimals effectively. And I have a lot of other cool things. So beyond just those basic data types, I have a couple other really good Python things. So I have a list, which you can consider an array. So I can say I'll have a bunch of different values in my list. And then I can have what's called a tuple, as in quintuple, not a tuple, which is very much like a list, but it's more static and it's really immutable, but it looks very similar. So here I can put in some values. And then the last data type I want to show you is a map or a dict. Python I refer to as a dict. It looks like a general object value. If you're familiar with JSON, it looks like a JSON value. And in this case now I can add some parameters to it. Let's set some key value pairs. And now I'm going to show you a quick what these look like. Now I'm going to break my rule and I'm going to print these out so you can see them pretty straightforward when I run them all. So I'll start with my string. I'm going to comment out my logging info for you because we don't want to see all that. And I'm not going to break my laws. I'm going to say logging.info and I'll show you that string. Now when you do a print or when you do a logging message, everything behind the scenes gets turned into a string. So you'll see what these look like as a string. And I find this really helpful to get kind of a visual understanding of what the data type does. So here we can see my string variable is a string value. When I log it, I get string value. Now we can logging.info my integer, logging.info my float. So I put a little underscore in front of the data type to make it understandable for you to, while you're watching this, but those are not necessary naming conventions. You can name these things whatever you want. So now you can see the integer comes out looking like an integer. The float comes looking out like a float. Now come the fun ones. Logging info, I'm going to show you the list. I'll run that first. And you can see it looks very similar to what it looks like as I typed it up here. Now I'll show you the tuple. Again, it looks like above. Logging.info, and I'm going to show you the dict. Now after I show you what these look like coming out, I'm going to show you a couple of functions on some of them that we're going to use. So you can see the tuple is a bunch of key value pairs. So, I'm sorry, the dict is a key value pairs. So the list has some important functions, and I'm going to talk about inserting a new value. So let's say I want to insert something at the beginning. I'll take my list and I'll insert a value, and I'll log that out again. Insert takes 2, so I need to tell it where. So I want to tell it to put it at the beginning. 0, since again we're in a computer language, 0 is the first. You can see I inserted that value at the beginning. All right, now that we've inserted something at the beginning, you can do that value, that offset anywhere. So I can insert something in the 4th position, 4th. I don't know how to spell 4th position. And we'll log that again. And you'll see it's at the 4th position. Now, if I want to add it to the end, I can't do a thing like a -1 for my position, but there's another function called append. So I can append a value at the end. And I now see, if I actually print it out, that value at the end. I'm going through this really quickly. Thanks to modern technology, you can come in and slow this down or watch it again, pause, etc. I'm going to make something fun. I'm going to show you my favorite list function. This works with strings, so I'm going to say, I want to log something new for you. So in a lot of use cases, you'll have a list of names or a list of addresses or a list of colors or something, and you want to print it out and you want to say, here's a nice comma-separated list or pipe-separated list. You can manually build a string and then output the string, but Python gives you a really nice way to do that. There's a function called join on the strings that takes in a list of a bunch of strings, and using its internal smarts, it will take that list and effectively make a, in this case, since I gave it a comma separated list. Now the cool part is, if I did that manually, I would, naively, I could end up with a comma at the end, a comma at the beginning. Using the join function, it just works. All right, now that you've seen with a couple of functions on logging, a couple of functions on the list, you can find the code online, and you can look at other things like popping to simulate a queue or simulate a stack. But I'm going to show you a couple other things we can do here. So like lists and tuples, we can reference the values by an index. So this will work with both the tuples as well as the list. So I'm going to take my tuple and I'm going to show you my 0th element, and then I'm going to show you my first element when I print these out. A little header for some separation. And now we will run to show you the 0th element is truly that 1. The first element is the number 2. Now we go back to our tuple, 0th element, 1 element, 2 and 3. And so when you're writing your code like this, if you're testing your input and output, you never want to naively look for anything in a list because you don't know how long that list is, or tuple. And so we can always use a length function on a tuple or on a list to say, how long is this? And then you would write the code that says, if the length of my tuple is greater than 1, meaning I have at least 2 elements, then I can look for that index. Look for that value by index. So let me run all that code, and length of tuple, I have my parentheses in the wrong spot. Run it, and you can say, okay, my first element, my second element, my 0th, which is first element, second element. My length is 4, right? Because I have 1, 2, 3, 4 items in that tuple. And then I can safely look for the first index because I know I have more than 1, which means I have at least 2. And if I have 2, I can get the second element by using index number 1. All right. The last one we're going to dig into a little bit more for now is this dictionary, Dict. So when I created, I'll make a new Dict here just to start over. I can say my key with a value, and I can inline create that Dict. So let's logging info, Dict section, logging info, new Dict to show you the whole Dict, and then I can access that key using the key name in the brackets. So when we run that, I will get an error because I did not use the word key. I'm going to show you that in a second. So here you can see I got value. So my Dict is key and value, and I've got the value by key name. Now you saw briefly that I got an error, and I'm going to show you why I got that error. So I was looking for missing a key that was not in there. So we can see my Dict does not have a key with the name of missing key. And so I get this error. Well, that stinks, because if we're looking for input from an API or a RESTful API call or a post with a JSON structure, I don't really know what's in there. So like we check the length up here, I have a few options. So with a Dict, I can check to see if a value is in there. So I can say, if the key, missing key, is in my Dict, then I can log it. And this should be safe. I don't get an error, I also don't get anything. Now, you can do that, or if you want to set a default value, we can also reference that with a get function, and I can look for missing key. Now, the cool thing about get is I can pass in a default. So I can say, it's effectively saying if missing key is not a member of new Dict, return this default value. So when I log that, because we know missing key is not in there, the get function returns a value. And so we saw that error, and the last thing I'm going to show you is a quick way of handling those errors, as well as showing that in the logging function. So what we'll do is we'll try something, and I'm going to log info new Dict, and I'm going to force an error, missing key, because we know the key is not in there. And we saw earlier I got this ugly error in there at the bottom, and when I get that error, my code stops running. It's called raising an exception. And so what we're doing here is we're going to put in a block of code. It's like try catch in Java, but here in Python it's a try and then an except. So if this function in the try block or anything in the try block causes an exception, we're going to catch it. And what we'll do here is we'll say logging.exception, there is an exception. And then we can get information about that exception, but my code will continue. My code will continue. See? And if I didn't have that except, my code would break. Now, while I'm doing a quick try except, I'm going to show you that there is something also called a finally block at the end. So most programming languages that have a try or exception handling process like this has a final block at the end, which happens no matter what. So I would say something like, I'm finally doing something. You use this for a few reasons. Primarily, you're going to use it for cleaning up resources or disconnecting from a database or closing a file handle that you have. This code is guaranteed to run even if there is no exception. So in this case, I'm causing that exception, and you can see that trace back, which is a stack trace. It shows you what happened. Now, let's duplicate this code into something that will not cause an exception, but you'll see that finally block still gets called. So here I'm getting and logging this default value. You'll notice lowercase versus upper to not confuse above. We will not see there's an exception like you do here for the first one, but you'll still see I'm finally doing something. And I'll change that so we see something different. Another time to finally do something. And then when I run that code, you will see no stack trace. If my code will continue is this first line here between the two try blocks, which is great. And then you'll see I'm logging that default value, which means this line of code did not cause an exception. My except block did not happen because I didn't throw an exception, but my finally block still happened. That's going to be key for us when we start getting into our more advanced applications in the next couple of videos when we do deal with files or we deal with database connections. So please come back. This is part 2 of my 6-part series on learning Python 3 in an hour. Please check me out at fowie.com. Find me on Twitter at Chris Fauerbach. And for now, thank you very much.